Hey guys, this is chapter 8 that we're going to be doing now. This is all about rational functions. If you remember, a rational number is just a fraction. So really a rational function is just a fraction. Okay? So an example of a rational function might be something like x plus 3 over, I don't know, 5x minus 4. That's a rational function. Okay, we're going to start talking really quick about inverse variation. I'm not going to spend too much time on this. Inverse variation is different than direct variation. Remember, this is a direct variation, y equals kx, or k is equal to y divided by x. Well, guess what? An inverse variation is going to be instead actually, oh, I totally take it back. This is a direct variation, right? Y equals kx. An inverse variation is going to be y is equal to k divided by x. Okay, that's an inverse variation. Okay, that's so. If I was going to figure out what k was in a direct variation, it's y divided by x. If I wanted to figure out what k was in an inverse variation, so wait, hold on, I should write this. This is a direct variation. This over here is an inverse variation. Okay, so k in this case is going to be, if I multiply both sides by x to get k by itself, it would be k is equal to x times y, okay? So just try to distinguish the two. If I was going to do an example about y varying directly with x, well, if you remember, it's going to be y equals kx, or k is equal to y divided by x. All right, so if I wanted to figure out directly, this is what we did way back when. If I wanted to do this, well, I would figure out what k is here. I would say k is equal to y divided by x, so it's negative 51 divided by 27. That's y divided by x. And that would equal the k over here, which would equal negative 17 over x. So I set up this proportion. So this is my k, right, for this problem here, and this is my k for this problem here. It's y over x and y over x. To solve this proportion, I would just cross multiply, and I would get negative 51x is equal to negative 17 times 27. If I go to my calculator, I multiply that out, I end up getting negative 51x is equal to negative 17 times 27. So I get negative 51x is equal to 459 divided by negative 51. Sorry, negative 459. Okay. I end up getting that x is equal to 9. Okay. This is a direct variation. All right. If I'm going to do an inverse variation, okay, so I'm going to skip this because we did these before. Actually, I'll do one of them. Just to remind you, for a direct variation, if I was looking for which ones were a direct variation, well, I would look at each k. K in this case is always going to be y divided by x for a direct variation. So k in this case would be negative 2 divided by negative 6, which comes out to be 1/3. This one right here is just going to be 1 over 3, and this one over here would be 4 over 12, which is equal to 1/3. So, sorry, 1/3. So, again, this is a direct variation, okay? And if I wanted you to write me an equation for this direct variation, y equals kx, well, clearly the k in this case is 1/3, so it would be y equals 1/3 x. That's your equation, okay? So now once we get to all of this inverse variation stuff, now my y is equal to k divided by x in an inverse variation, or my k is equal to x times y, okay? So let's look really quick. What does that graph look like? Well, the graph is going to look something like this, okay? So I want you to think of the biggest difference, okay? In a direct variation, if I go back to this screen here, look, as my x is as my x is increasing, look, I go from negative 6 to positive 3 to positive 12. That means my y is also increasing. So as your x is increasing, your y should be doing the same thing, increasing. If your x was decreasing, your y would be decreasing. However, if you look at an inverse variation, watch, check it out. This is an inverse variation right here. Watch what's happening here. As my x is increasing. Look, it's going from 3 to 6, from 6 to 12, to 12 to 20. It's getting higher and higher. Look what's happening to my y. It's decreasing, okay? So that's one way you could tell the difference, okay? Let's just look really quickly here. If you remember, on an inverse variation, I said that k is equal to x times y. Well, look, right here. My x, my y times y is 3 times 8, which is 24. 6 times 4, 24. 12 times 2, 24. 24 times 1, 24. So this is an inverse variation. Okay, remember in an inverse variation, it's equal to, y is equal to k divided by x. So the equation for this would be, well, I just figured out my k is 24. It would be y equals 24 divided by x. Okay, that would be my equation. Okay, all right. So if I wanted to do one of these and I wanted to figure out, is this an indirect variation, an inverse variation, or neither? Well, let's do this out, okay? Well, let's first check. If I look at this, my x is 0.8, 0.6, 0.4. So in other words, my x is going down. What's going on with my y? My y is going up. It's going from 0.9 to 1.2 to 1.8. So there's no way this thing could be a direct variation. So I could check to see if maybe it's an inverse variation. So let's check the k's. On an inverse variation, the k is equal to x times y. So let's multiply those two together. 0.8 times 0.9 comes out to be 0.72. Okay, let's multiply these two together. 0.6 times 1.2 is 0.72. Let's multiply these. 0.4 times 1.8 comes out to be 0.72. So this must be an inverse variation, and my k is 0.72, so my equation will be y is equal to 0.72 divided by x. All right, let's check this one. My x's are going up because I'm going from 2 to 4 to 6. My y's are going down. So this cannot be a direct variation. So the only thing it could possibly be again is an inverse variation where my k is equal to x times y. So let's multiply 2 times 0.32, or sorry, 3.2. I get 6.4. Here I'm going to multiply 4 times 1.6. Again, I get 6.4. And now I'm going to multiply 6 times 1.1. All right, I did, and I got 6.6. So you know what? My k's are not always equal, so this is neither. All right, let's look at C. Well, my x's are going up. 1.2, sorry about that. 1.2 to 1.4, so these are going up. My y's are also going up. So this is a possible direct variation. In a direct variation, my k is equal to y divided by x, right? So let's try that. So we do 18 over 1.2. So 18 divided by 1.2, I get 15. Let's divide, let's divide 21 divided by 1.4. I get 15. And let's divide 24 divided by 1.6. I get 15. So this is clearly a direct variation, and the first one was an IV. So direct variation, and my equation for direct variation is going to be y equals kx, right? So it will be y is equal to 15x. Okay? Moving on. Don't forget, you guys, you can always just pause the video if I'm going too fast. Right? I'm telling you that this is an inverse variation, and I want you to write me an equation. Well, in an inverse variation, your k is equal to x times y, which in this case is going to equal negative 7 times 4, which is equal to negative 28. And don't forget, here's the equation for an inverse variation. It's y is equal to k divided by x. So y is equal to negative 28 divided by x. Okay, moving on. I'm going to let you guys try that one. You can pause the video first. Don't worry about that one. Let's just move on. I'm going to let you guys do the homework instead. This is kind of what a graph looks like. See this stuff here? I don't really care about this. I do care about this combined variation. So a combined variation, quantities can vary with respect to each other in different ways. So if I said it was going to vary directly with x to the third, it would be y equals k times x to the third. But it can also vary inversely. So if it varies inversely, check it out. I'm putting the x down into the denominator. So if I say it's going to vary directly with x to the third, I'm going to put y equals k times x to the third. If I'm going to say it varies inversely, it's going to go down into the denominator. Okay, so for example, I'm also going to talk about something called a joint variation. If z varies directly with x and y, I can have an x and a y after the k. Okay, so z would equal k times x times y. All right. So if I say, here's my combined one. If I say that z varies directly with x and inversely with y. Okay, so ready? This is what that means. Z is going to vary directly with x, so I'm going to have this k here. If I say directly with x, that means the x is going to go up in the denominator. That's what directly means. And inversely with y, that means the y is going to go down in the denominator. So now when I start the next part of this question and I say when z equals 2, I'm now going to substitute in a 2 for the z, right there, equals now, I have an x for the k. An x for is 12, so I'm going to have k here. I'm going to multiply that by 12, right? I'm substituting for the x. And y is 3. So I'm going to put the y in, a 3 in for the y. So I want to find, so I've just plugged in. Okay, so first thing you're going to do, like I said, is write the equation. Directly means in the numerator. Inversely means put it in the denominator. And now the second part is this part here. I substituted in. The third part of this question is I'm going to find z when x is 4 and y is 6. So I have to do this. Before I get to that third part, I need to solve for k. So check it out. I've got 2 is equal to 12k over 3. Well, I can reduce that 12 over 3 to a 4. So 2 is equal to 4k. To solve for k, I divide by 4, divide by 4. So I've got that k is equal to 2 over 4, or 1/2. All right, so now I figured out that k is 1/2. Now my next part, I want to find z when x equals 4 and y equals 6. Well, now I'm going to go back to using my original equation I came up. Z will equal k, which I now know is 1/2, times x, which I know is 4. I just said 4, divided by 6, because that's my y. All right, so now I keep going with this. What's 1/2 divided 1/2 times 4, which is 2? 2 over 6 is 1/3. So my final answer here is that z is equal to 1/3. Okay, I know that's a lot. You might want to pause your video and go through that again. Okay, I want you guys to try that one, so I want you to pause your video and I want you to try this. Okay, we're going to do this one together now that you've tried it. Hopefully you got it right. All right, x varies directly with y and inversely with z. So here's how I'm going to write this equation. X varies directly with y, so I got x equals k times y, but inversely with z, so I divide by z. Okay, that's part 1. That's my equation I'm working with. When z equals 20, now part 2, I'm going to sub in. So when z equals 20, I'm going to plug in 20 for z. So that's down here. And x equals 6, so 6 is over here. I don't have k yet. And y equals 14. Okay, so that's my equation that I'm working with. I'm going to, if you remember, I'm going to solve for k. So I can do this. I can multiply both sides by, I can reduce this fraction if I want, but I don't want to do that. Right now I'm just going to multiply both sides by 20. So if I multiply both by 20, it cancels and cancels. Okay, sorry. I am left with this. 14k is equal to 6 times 4, which is 120. And now lastly, I'm going to divide by 14. Okay, so 120, if I go to my calculator, 120 divided by 14, I come up with some crazy decimal. So instead what I'm going to do is reduce this fraction. Okay, I don't want to come up with the crazy decimal. I'm going to instead divide everything by 2. So this comes out to be 60 over 7. So k equals 60 over 7. All right, the last part of this is going to be, I'm going to do this part right here. Okay, I want to find z when, so z is down here in the denominator, when x equals 10, so 10, I'm just plugging it back to my original equation, is equal to 6, I know that k is 60 over 7, I just figured that out, and my y in this case is 7, so this is going to be times 7, I'm substituting in for y. Alright, so watch, this is going to work out nicely. My 60 over 7 times 7, these two cancel out. I'm left with 10 is equal to 60 over z. In order to solve for z, I'm going to do this. I'm going to multiply both sides by z. Okay, so now I've got 60 is equal to 10z. Divide by 10, divide by 10, and I get z is equal to 6. Okay, so if you want to rewind this video here and go back and look at that, go for it. Okay, here's a joint variation one. I'm going to talk about this. Whenever I say varies jointly, I'm going to put it up in the denominator. Okay, so watch this. I'm sorry, I'm going to put it up in the numerator. Y varies jointly with x and y. So ready? Y is equal to k times x times z. That's my equation I'm working with, okay? When I look at this next part, if I say when y equals 20, x equals 5, and z equals 1, here's what I mean by this. 20 is equal to k times 5 times 1. I just substituted everything in, and I want to now solve for k. So 20 is equal to 5k. Divide by 5, divide by 5. K is equal to 20 divided by 5, which is 4. Okay, that solved for k. Now I have to do the last part. Find y when x equals 3 and z equals 2. So y is equal to, well, now I just figured out that k is 4. I'm substituting into this equation, guys. X is equal to 3 and z is equal to 2. So now I've got y is equal to 5 times 3, which is 15, times 2 is 30. So that's my final answer, y equals 30. Okay? Moving on, I want you guys to try this one. This will be our last problem. Okay, ready, go. I'm going to pause the video and try it. Okay, now we're going to work it out together. Hopefully you got this. Y varies jointly with x and y. Okay, so now from there, I'm going to, now part 2, I'm going to plug in these 3 things into the equation I just came up with. So I'm going to say y, which is 10, is equal to k times 2 times 3. So now I'm going to solve for k. I've got 10 is equal to 6k. Divide by 6, divide by 6. K equals 10 over 6, but I'm going to reduce that to 5 over 3. Okay, so that's my k. And then the last part of this is I'm going to do this part right here. I want to find y when x equals 5 and z equals 6. So I'm going to plug in this 5 over 3 for the k times 5 times 6. Okay, so now what do I have here? I've got 5 over 3 times 30. All right, when I do this out, I can cross cancel and make that a 10. So it would be y is equal to 5 times 10, or 50. Okay, hopefully you got that. You can kind of go back and look. This I don't care about, this I don't care about, so we are done. Thanks for listening, guys. Try the homework in 8-1 and look at the other video for 8-2.